So lenses are refracting surfaces. The surface which refracts the light is simply known as the lens, and we have two types of lens. A lens which is thinner at the edges and thicker at the center. This is called convex lens. And opposite, the lens which is thicker near the edges and thinner at the center, that is known as concave lens. You will learn in detail about convex lens. You will not learn anything about concave lens. So convex lens in detail, you will study how the light passes through a convex lens. But for a concave lens, just introduction will be there, but nothing else more than that. So example, how these lenses work, or what happened to the light when the light passes through these lenses. So example, for a convex lens, so you will use the concept of refraction. Both convex and concave lens are made up of glass, but the difference, the convex lens is thicker at the center and it is thinner near the edges. So it refracts the light. How it refracts the light? Example, the light strike the lens. The light which strike the lens, that light is called incident. Then we draw the normal. The normal is always perpendicular to the surface. The line which is perpendicular to the surface, that's called a normal. So if this is a surface, so we have to draw a perpendicular or 90 degree. So when I draw a perpendicular or 90 degree, so this yellow line is representing the normal. Why? Because for a normal, the surface and the normal are always 90 degrees with each other. So moving from air, because the light is in air and it enters the glass. So moving from air to glass, what will happen? It will bend towards the normal or away from normal. Means what path it will take? This is bent away, going away, and this is bent towards. What will happen? Moving from air to glass, bend away, go away from the normal or go towards the normal. So moving from air to glass, what we'll observe? We'll observe it will bend towards the normal. So what will be the path of the light when it passes? So it will bend towards the normal. The light which bend towards the normal, that's called a refracted ray. Now when it strikes the surface, again we have to draw another normal, which is perpendicular to the surface. So if this is a surface or a part of a surface, what we have to do? We have to draw a normal. So normal is always perpendicular to surface. So this will be the normal. The yellow line is representing the normal to the surface. So direction of the normal is depending on the surface itself. It is not fixed because the surface is curved out inward. That's why the normal was up. It's outward, so normal is down. Now what happened moving from glass to air? What will happen to the light? It will bend towards the normal or away from the normal. Moving from glass to air again. So it will bend away from the normal. So when we complete the path, so this is how the light is coming out. If I draw up, it means it is bending towards the normal. So what I will do, I will bend it down. So what happened? Moving from air to glass, it bent towards the normal, and moving from glass to air, it bent away from the normal. So this is how a refraction occur in a convex lens. The light changes the speed when it travels from air to glass and then from glass to air. If another light strike the surface, so this is a convex lens, and the light strike the surface exactly at the normal. Right? So what will happen? If this is a surface, like this part is a surface, so when we draw the normal is perpendicular to the surface or 90 degree to the surface. So you can see here the light is passing along the normal or same as the direction of the normal. So when the light passes or move along the normal, it does not change the direction. Only thing which change is the speed. And when we draw the normal at other end, because it's also in the same as direction of the normal is perpendicular to the surface. So what will happen? It will continue to move in a straight line without changing a direction. So if light is passing along the normal, it passes straight. But in the previous example, the light was not passing along the normal, it was making certain angle with the normal. So when it is making certain angle with the normal, what will happen? Moving from air to glass, it will bend towards the normal, and moving from glass to air, it will bend away from the normal. Is it clear? The refraction in convex lens. So whenever a light moves from air to glass, it will bend towards the normal. Normal is always perpendicular to surface. And when it moves from glass to air, it will bend away from the normal. So in this case, because it was not passing along the normal, that's why we see a change in direction. But if the light is passing along the normal, same as the direction of normal, the only thing what we'll observe is a change in speed, but we don't observe any change in direction. Moving from air to glass, the light will slow down, and moving again from glass to air, the light will speed up, or it will be fast. Any doubt in this refraction of a light through a convex lens? This is a convex lens, a lens which is thicker at the center and thinner near the edges. That's called a convex lens. If the light strikes this convex lens, this light is known as incident light. Imaginary line which is perpendicular to the surface is called normal. So when we draw a normal, because this is a surface, so we have to draw 90 degree to the surface. So when we draw 90 degree to the surface, so yellow line is representing a normal. As we discussed earlier, when the light travels from air to glass, it will bend towards the normal, its speed will decrease. So what we will observe? We'll observe that the light bend towards the normal. And what happened? As it strikes the surface again, we have to draw another normal for a glass to air boundary. So this is a normal. Moving from glass to air, it will bend further away from normal. So this is a path which the light follow. This is a path which the light follow when it is passing along, not passing along the normal, it is making certain angle with the normal. But if a light is passing along the normal, like this is a surface, so if I draw a normal here, the yellow line is representing a normal. So normal is like this, perpendicular to surface. Normal is perpendicular to surface. If a light is passing along the normal, same as the direction of the normal, so what we will observe? We'll observe that the light does not changes the direction, it only changes the speed. So moving from air to glass, it will slow down, and again moving from glass to air, it will speed up. But because it was passing along the normal, that is why there is no change in direction. So for lenses, what you have to learn, for a convex lens, there are certain terms which you have to learn. So convex lens is also known as a converging lens. Why we call a converging lens? Because what happened when the light rays are passing through this lens, they all converge at one point. Now, for a convex lens, you have to learn 3 points. Number one, like this is a convex lens. The imaginary line, in reality it's not there. The imaginary line which is passing through the center of the lens, this line is called principal axis. So imaginary line which is passing through the center of the lens, that imaginary line, this is just an imagination. This imaginary line is known as principal axis. The center of the lens, is known as optical center. The lens is having a center we call optical center. Then what happened when the light is passing through a convex lens? This light first bend towards the normal and then further bend away from the normal. So these light rays converge at one point, means meet at one point.
Sir, how they bend away from the normal?
How they bend away from the normal? Because the normal is different according to the surface. As they're traveling, the light is traveling from air to glass. So the point where all these light rays converge or meet, that point is known as focus or principal focus. So the point where all the light rays converge, that point is called principal focus. And the distance between the optical center and the principal focus is called focal length. So these are the points which you have to learn. I will answer your question, Hashim, how the light is converged or bent away from normal. So this is the optical center. The center of a lens is called optical center. The point where all the light rays converge, that's called principal focus. The distance between the principal focus and the focus point and the center of the lens or optical center, that distance is called focal length. Principal focus is denoted by F. Or focal length is the distance from center of the lens to the point where all the light rays converge. Then we also define a point 2f. What is the meaning of 2f? 2f means double of focus. Like example, if the focal length is 10 centimeter, if focal length is 10 centimeter, what is 2f? Where will be 2f?
20 centimeter.
So 2f will be 20 centimeter. So just a reference point, that the point which is twice as distance of focus is called 2f. And same thing, because in this case I draw a light is coming from left and moving towards right, but it can happen other way around. So you may have a focus on the left hand side and 2f also on the left hand side. Why? Because in this example all the light rays are moving from left to right, but what will happen if it was other way around? So imaginary line which is perpendicular, first a convex lens, a lens which is thicker at the center and thinner near the edges, that's called a convex lens. Imaginary line the imaginary line which is passing through the center of the lens, what we call this line? Imaginary line which is passing through the center. Yeah, that is called principal axis. The point where the line, the center of the lens, what we call? The center of the lens is called optical center. And if the light rays are moving from left to right, in this case it's moving from right to left. So this is the direction in which the light is moving. If I draw a normal, normal is always 90 degree or perpendicular to surface. So when I draw the normal, normal will be like this. So moving from air to glass, where it will bend? Towards the normal or away from normal? Moving from air to glass.
Sir, again, what is the normal?
Normal is always 90 degree or perpendicular to surface. So this yellow line which I drew first is a normal. because when you check the surface, this is a surface at which the light strike. So draw a perpendicular or 90-degree to this surface. So when you draw a perpendicular line to the surface, that line is called normal. So yellow line is representing a normal. As it moves from air to glass, it will bend towards the normal. So if this is a light, this is how it, if it does not bend, it will move like this. If it bend away, then it will be up. It bend towards the normal, so it will be down. So moving from air to glass, you can see it bend towards the normal. Now we have to draw another normal to this surface. So when I draw, this is a surface, so when I draw a normal or a perpendicular line, so this will be the normal according to the surface, the perpendicular. So moving from glass to air, as it moves from glass to air, like example, this is when it follows straight. But if it bent towards the normal, I will make it up. It bent away from normal, that's why I will make it down. So when the light travels from air to glass, it bent towards the normal. Moving from glass to air, it bent away from the normal. So all these light rays which strike the glass, after a refraction, as these light rays strike, after a refraction, these light rays will converge at one point. When these light rays converge at one point, what we call that point? We call that as principal focus, or we can say a focus. So when all the light rays converge at one point, we call that point as principal focus or focus. You can also say focus. And the distance between this focus and the center of the lens, that distance is known as focal length, which is denoted by f. And if focal length is f, there's another point which we say 2f. 2f means double of focus. Like if focal length is 5 centimeter, 2f will be 10 centimeter. If focal length is 15 centimeter, 2f will be 30 centimeter. So I want you to draw first these parts of a convex lens. A convex lens is also known as a converging lens because it tends to converge all the light rays to one point. Copy this one. Finish writing this? If I draw a normal here for the black lines are the normal according to the surface. But in the figure, you don't have to draw normal in this one. Reason for that, because just that this is just for explanation I use. It's not by calculation. This is a previous, those who want to take the screenshot or the picture. That's the first one I drew. And this one is the second one. Now what we observe three types of deviation. How the movement of light through convex lens. So there are three possibilities. Number one, if light is parallel to principal axis, it will travel, pass through focus of other side. So if light is parallel to principal axis, it will pass through focus of other side. If light is passing through the focus, it will go parallel to principal axis without, it will go parallel to principal axis of other side. I'll draw each so you will understand. And the third one, if light is passing through the center of the lens, it will not change its direction. So these are the three rays which can be used to explain how image is formed by a convex lens. The first one, if a light is parallel to principal axis, you can see here, if this is a lens, yes, you have to copy this as well. I will explain and you will copy. If this is a lens, imaginary line, it's not real, it's just imagination, imaginary line, which is at the center of the lens, we call that as principal axis. And for on the principal axis, there are always 2 points, focus and 2f, f and 2f. And there is a center of the lens, which is called optical center. Now, if the light is parallel to principal axis, any light is there which is parallel to principal axis. So example, this is a light which is parallel to principal axis. From where it will pass, it bend towards the normal and then bend away from normal. But from which point it will pass through, it will always pass through focus. So if any light is there which is parallel to principal axis, it can be any light which is parallel to principal axis, it will always pass through the focus. And if light is passing through the focus, the second one, this is a convex lens, imaginary line which is perpendicular to the surface. This imaginary line is called principal axis. On the principal axis, you will always have a point focus f and 2f, and other side as well, f and 2f. So imaginary line which is passing through the center is principal axis. Now, if the light is passing through focus, it will go parallel. What does it mean? Like example, if this is a light, if the light is passing through the focus of the lens, so this is a focus and light is passing through the focus. So how it will go? It will travel parallel to principal axis. That's the second ray. And if the light is passing through the center of the lens, it will not change its direction. It will pass undeflectedly. So this is a convex lens. Imaginary line which is perpendicular to the surface, that imaginary line is known as the normal. Oh, sorry, principal axis, not normal. So if a light is passing through the center of the lens without any deviation, it will continue its direction. It will not change its direction. So these are the three ways the light can pass through a convex lens. Number one, a light can be parallel to principal axis. It will passes through focus. If it is passing through the focus, it will go parallel to other side. And if it is passing through the center of the lens, then it will go continue in the same direction without changing the direction. These rays can be used because the next topic I will discuss how the image can be formed by a convex lens. So we will discuss in the next session. I want you to copy this part and remember these directions. If light is parallel, it will pass through focus. If it is passing through focus, it will go parallel. And if it is passing through the center of the lens, then without any change in direction, it will pass straight.